Okay. Hello everyone. My name is Pratiksha Dharekar and uh, the question is that maximum subarray. So the question in that question given an integer array nums, find the subarray with the largest sum and return its sum. Okay. So firstly we need to basically understand that what is the subarray. Subarray is the continuous element of an array. So here subarray may be a 1 minus 3 4. It is also a subarray. Individual element is also a subarray. Suppose the 4 is an individual element, this is also a subarray. And also we suppose we take the 1 minus 3 1 minus sorry we take the 1 minus 3 and lie directly minus 1. So this is not a subarray because this is a disconnected. We need to find the contiguous element of an array. This is a subsequence. So the question is that we need to find the maximum subarray sum. Okay, so the basic approach, how to do the brute force approach that first comes in our mind, that is the to finding all the subarrays and calculating the sum of each subarray and returning the maximum subarray sum from that. So to calculate all the subarrays, the basic approach is that suppose we applying the here firstly we apply the three loops. First is starting from minus 2, uh, integerize starting from minus 2, and the first subarray is the minus 2, then next subarray is minus 2 1, then next is minus 2 1 minus 3. Like that we find all subarrays, then we increase the I, and the next subarray is 1, then we add that 1 minus 3, then 1 minus 3 4. Like that we find all the subarrays. So I written here the code. First declare the we need to first declare that maximum to the minus infinity, because to the minimum value I declare here minus infinity. So I apply the first loop starting from 0 to nums dot length, that is array length, and apply the next loop that which is starting from the I and go to the end of the array, and here I calculating the sum of each subarray, and apply the another loop that is k starting from I going up to the j and calculating the sum of the current subarray, and updating here by using mat.max function, updating the sum of the subarray and return the subarray. So the time complexity of this code is a big of n cube, means not exactly big of n cube but near to the big of n cube, because here we're starting from the loop from the I, because that's why the time complexity is not exactly big of n cube, nearly big of n cube. And the space complexity is big of n, sorry, the space complexity is big of 1. We are not using any extra space, so this is a very high time complexity. We need to optimize this code. We need to do this is big of n square or big of n time complexity. So in question the constraints are given, that is a 10 raised to 5. So we need to do this question in big of n time complexity. So because big of n square, the 10 raised to it goes up to the 10 raised to 6, so the time limit it gets error, that is a time limit exceeded. So another better approach is very simple. We can just so here we can see that here we find the each subarray. First we find the minus 2 subarray, it's okay, no problem. Then we find minus 2 1, that is the next subarray, no problem. Then we find the minus 2 1 minus 3 subarray. So here what we do, we clearly we suppose clearly observe this pattern, that is we reiterating from the from I it's reiterating from that subarray. So instead of reiterating, we use the previous sum and we just add the next element in that subarray, like that. Suppose the first subarray is minus 2, uh, we next subarray is minus 2 1, no problem. The next is minus 2 1 minus 3. We reiterating, right? Like so we we store the previous sum and we just add the next element in that, and we update it with the max value, like that. So we no need to return write this code, right? So we can update sum here, and here what we do, here we just sum plus equals to nums of j. Like it reduces the time complexity, and we update the sum and max, and right, that's it, no problem. So the time complexity of this code is big of n square, and the space complexity is big of 1. We are not using any extra space. So it also not running, it gives the error that is the time limit exceeded, because the constraint are 10 raised to 5 and it goes to the 10 raised to 6. So that's why, yeah, time limit exceeded. So also we need to optimize this code. We need to solve this code in big of n time complexity. So what, how can we do this? The basic algorithm, the algorithm that is a cadence algorithm, we use here a cadence algorithm to solve this question. So cadence algorithm is a very simple algorithm. Um, so uh, let's see here. We declare it. We declare integer max with the minus infinity and sum with the 0. Okay. We start from -2, right? We start from -2. We add it to the sum. Suppose we start from -2. Okay, and we add it to the we we add -2 with the sum plus equals to -2 is array of 0. Okay, no problem. So, and we update the maximum value. Obviously the minus infinity is less than -2, -2 is greater than minus infinity, so we update it with the -2, no problem. Got it. So the next is we move forward and we go to the 1. So means moving forward, so we cannot go with the negative sum because it reduces the overall sum of the subarray. So means suppose we go to the -2 1, it the total sum is the -1, and we do not go with the -2, then the total sum is the 1. So there is no, means it is not making any sense that is we moving with the negative sum. If the means we apply here one condition, that if my sum is less than 0, then my initial sum, make it to the initial sum and move forward. Like that, we go to the 1 and make my sum that is a 1, and update the maximum sum is -2 1, the max is 1, so we can update it to the 1. So again we go to the -3 uh, we can go with the positive value because it is adding the summation, because it is increasing the sum. So -3 plus 1, it become the -2, and the sum is -2, which is less than 1, so we not updating the maximum. The next is 4. We are adding 4 to the -2. 4 uh, plus -2, that is a 2. Like, so the 2, obviously 2 is greater than 1, so we add the maximum sum also. Then we go to the -1. We obviously we are going with the positive value. So here we are doing the mistake, that is we are going forward with the negative sum. We can't forward with the negative sum, right? So that is the big mistake that I have done here. Sorry for that. So we are 1, the maximum sum is 1, that is a 1, and here we add, suppose we add a -3, then it becomes the -2. We can't go with the -2, so suppose we make it as a 0, right? So the next is 4. We add sum, that is a 4, in sum 4, the maximum sum becomes the 1 and 4, the maximum sum is 4. We update it to the maximum sum. Then we go to the -1. we add in the sum, that is 3, it becomes 3. 4 minus 3, 4 plus minus 3 is a 3, and the maximum sum is 4. We cannot update this, so again we go to the 2. Suppose we add 2 in this, suppose it becomes the 5. So the 4 is less than 5, so we update the maximum sum. Then next is a 1, the next is a 1, we add 1 in this, that becomes the 6, and the 5 is less than 6, so we update the maximum sum, that is with 6. Then we go to the -5, the minus, we add it to the -5, it becomes the 1, so maximum sum is greater than 1, so we are not updating. So we go to the next, that is a 4, and 4 plus 1, it becomes the 5, but still maximum sum is 6, we are not updating. So that's how we are finding the maximum subarray sum by using Kadant's algorithm. Let's write a code for that. So what we do here, we are let's erase this code. We are declaring integer sum at starting as a 0, and okay, so we are means we are declaring one condition, that if my sum is less than 0, then make it as 0, make it 0, no problem. And we add sum plus equals to my nums of I, and we update it with the max by using math.max. That is my sum, and sorry, and we return the maximum sum. That's it. The time complexity of this code is big of n, and we are not using any extra space. The space complexity is big of 1. So this is the optimal approach, and it gives me the correct approach, right? So that's it. Thank you.